Alright, so the first problem of this practice set is asking us for the force of gravity between the moon and the sun. And they give us that the mass of the moon is 7.35 times 10 to the 22 kilograms, and the mass of the sun is 1.989 times 10 to the 30th, which is much bigger, as we already know. And the distance between them is 1.47 times 10 to the 11th meters. And then there is our constant that we're going to use for our formula of gravity between two objects of mass. So it's big G, and then we have m1 times m2. This big G is also being multiplied, so let's just go ahead and write it on top anyways. It doesn't matter whether you multiply it first and then divide, or divide and then multiply the G later on. Anyways, this is divided by the distance squared. Again, very important, squared. And so we seem to have every single bit of information. We can just start plugging in what we know. So G is 6.67 times 10 to the negative 11th, and the units to that are newtons, and then we have meters squared, and then we have kilograms to the negative 2. Let's just put parentheses around that to keep it together. Now we have m1. I'm going to say m1 equals the mass of the moon. So of moon, which is 7.35 times 10 to the 22nd kilograms. Make sure we keep all our units. And then finally, the mass of the sun is 1.989 times 10 to the 30th kilograms. All of that is being divided by the distance, which is 1.47 times 10 to the 11th. But again, all of this is squared. So everything seems to align. Oh, let me put meters in here. So now we can go to Desmos, which I just closed. So let me bring it back up. There it is. And now we can start using our parentheses, and it's 6.67 times 10 to the negative 11. Now make sure we select on the next part so that we can put our parentheses. Make sure you select over, sorry. And then we have the mass of the moon, which we said 7.35 times 10 to the 22nd power of kilograms, and then select over, put your parentheses. Finally, the mass of the sun is 1.989 times 10 to the 30th power. Put a parentheses over there. Now we're dividing by parentheses 1.47 times 10 to the 11th. We can't forget that it is all squared. So finally we see that the answer is 4.5 times 10 to the 20th. Go back to normal mobility, which equals 4.5 times 10 to the 20th newtons. We see that all our units do cancel. We have meters squared and meters squared, and we have kilograms and kilogram, which cancels with this kilogram to the negative second. And we're left with just newtons. Alrighty.